Hello, and welcome to this exclusive webinar, Die Cutting, Overcoming Challenges with Performance and Efficiency, brought to you by RotoMetrics and FlexoTech magazine. I'm Andy Knaggs, the editor of FlexoTech. I'm joined today by three speakers from RotoMetrics. May I introduce Thomas Eberhardt, Sales Director, EMEA, Neil Lilly, Regional Sales Director, UK and Ireland, and European Technical Service Manager at RotoMetrics, Dean Morris. Over the next 45 minutes or so, we will be helping you to discover practical die cutting strategies that can help you enhance precision, reduce waste, and boost overall productivity. We will be seeking to give you answers and solutions to common die cutting issues, such as challenges when converting thin films, experiencing short life on rotary tooling when converting abrasive materials, and the waste management solutions that are most appropriate in different scenarios. At the end of the presentation by our speakers, we will hopefully have some time for the panel to address any questions you may have. Please pop those questions into the space provided and we'll get to them at the end. Following the webinar session today, all attendees will receive an email with a link that allows them to watch the presentations again. So don't worry if you miss something first time around. And with that, I think it's time for me to depart center stage and hand over to Thomas so that we can get stuck into the real meat of the webinar. Lots of great insights to come. So Thomas, over to you.
Thank you. Let me start by saying on behalf of RotoMetrics, a Maxcess brand, that we'd like to thank you all for attending this webinar. I'd also like to say thanks to Andy for facilitating this. Dean, Neil, and I have made a presentation focused on overcoming die cutting challenges regarding performance and efficiency. We'll talk about good household, that is service and maintenance. We'll talk about using the right tooling to overcome challenges. Again, focus on service, maintenance, and we will finish, of course, with the Q&A. Go to the next slide, please. Maxcess have globally around 2,200 highly qualified employees focused on web handling. Our business is divided into 7 brands evolving around the converting line. However, today we're going to be very specific and talk about what's happening in that yellow box, which is where the cutting takes place. That being said, word is to you, Dean. You're muted. Dean?
Yeah, so, yes?
You are muted.
No.
Thomas, have you finished your section?
Hey, I'm done. I said the words over to you, Dean.
Can you hear me?
Yeah.
Okay, excellent. So, ladies and gentlemen, thank you very much for joining us. Like Thomas said, obviously we all got different die cut challenges throughout the industry. Substrates, adhesive, whether it be converting, we know that our liners are becoming much thinner. The variations are changing. Adhesives, changes in adhesives becoming more aggressive, and obviously the frequency that you run with the liner changes based on short versus long runs. And of course, one of these small aspects we're just going to show you today is how we can overcome these challenges for performance and efficiency. One is looking at good housekeeping, which is a training scheme that I hold myself throughout the UK and Europe, looking at different aspects of what we see in the industry as, I wouldn't say bad things, but we do see things that can be fixed and easily solved by press operators. So it's a presentation that we will do in your facility for all your press teams and managers alike. Secondly, we'll be looking at the right tooling for the job, and of course, achieving the right cut depth also. So, first of all, what we call is getting our house in order, because there's many different factors that are involved with the tooling's lifespan. We know this. Some are based on mechanics. When I say mechanics, it's the gears, the running cutters itself, the die station. Some are environmental, which it can be temperature changes throughout the seasons, like hot melt adhesives in the summer. But many of these different aspects are all under our control, or should I say, your control. So let's take a look at these. So the factors that we look at for influencing the die cut process. First off, we've got web tensions. Having web tension too tight or too slack is obviously going to change the way that the die cuts. It'll change the label size. It can also change the way that the web itself, like the liner, snaps. Speed. We know that turning the press up is going to put more product off the end of the press, but again, you have different cutting issues. You increase heat, you change the tensions, and of course also you're having flow as well and curing issues. Materials constantly changing throughout the industry, and this is something that we really can't stop happening, because we've seen differences in the way that the liners are changing regarding calipers. Face stocks and adhesives are becoming more challenging. And then think about the stability of your die station or your truck. How stable is the die station? Are the torque settings correct on the bolts? Pressure. We know that adding too much pressure onto the dies can prematurely wear them. So why add pressure when you don't actually need it? And image layout as well. It's lovely having these beautiful labels on these bottles, you know, different star shapes and square corners. But can you actually achieve a running speed with these images? And this is something that we do help with as well. Cylinder and cut condition, and that's what we're going to touch base on in the next few slides. How good are your cylinders? How good are your mag cylinders? Are they in tolerance? Are your anvils up to specification? Strip path. There's never always one strip path for every single label, for every single material. So try not to pigeonhole yourself in adding just one strip path to the press. And finally, probably the biggest one we see in the industry still is heat, friction, or temperature. So if we take a look at the die station, you've got your rotary die, you've got your anvil and your support anvil, all running in correlation with each other, all creating friction because they're under pressure. And of course, all these have to run in correlation with each other with the mag cylinder, because on the flexible die system, using the magnetic cylinder, this is the base for all your conversion. Because if there's something wrong with these, it's the key foundation of everything that you have to do. So having a stable, even base reduces stress on the die station and also stress on the operator as well. So let's have a look at just brief flexible die terminology. And I apologize if I'm telling everybody to suck eggs here, because we just have to make sure that we understand, because we all talk in different languages, I must admit. So when we're talking TBH, we're talking the total plate height. When we're looking at clearance, we're looking at the gap between the blade itself and the anvil. And when we look at the air gap, we're looking at the base of the magnetic cylinder versus the anvil. And typically your industry standard air gap is 480 microns. If we look at that into specifics for the data relation and add the magnetic cylinder bearers and the base, you can still see exactly the same schematics we've seen in the previous slide. But the key thing is the clearance. And that clearance is the specific air gap between the blade tip and the anvil surface. And this is where we've set our flexible die at based on your face material, adhesive, application requirements. And if there's any deviation in the anvil surface, then that changes. And that also changes the TPH gap as well. And if you're cutting thicker materials, like I say, industry standard is 480 microns. We can make up to 1.2 millimeter flexible dies for thicker materials. But if your mag base is worn, then it's going to cut deeper into your backing material, and it's going to reduce the gap for that material to fit into. And I'm going to say this several times, the correlation between the mag cylinder, the flexible die, and the anvil has to be 100% specific, because all these are very, very tight tolerance tools. And if we're making tight tolerance flexible dies, even to cut paper to a glassine, If everything else is out of specification, it's going to give you, as press operators or managers, difficulties to try and set up. As when you're cutting high speed to the liner, whether it be a PET liner or a polypropylene liner or craft or glassine, deviations are going to give you cut throughs, and the only way to change that is for the press team to play around with pressures and adding or subtracting the pressure through the hydrojet. And of course, by the press team having to add lots of pressure, this creates thermal expansion. And this is where the truck, the anvil, and the die and the mag run in contact with each other, as you can see on that slide, all the areas in red. This is where friction occurs, and it doesn't matter how fast or how slow you run it, it still occurs throughout the system. And what you'll find is, being as the support roll is probably the only static 100% locked in part in that system, the anvil, the mag or the solid die, and also the truck are floating. And of course, as these elements expand through heat, because that's what happens with steel, the only way then is to move upwards. And what you'll find is, if you're running your pressure gauge at 700 psi like this is, that pressure gauge will slowly creep up all by itself. And that's because heat's involved, it's expanding. So what do we do about that, and how can we see it? Well, unfortunately, if it gets to the stage where you can see burnishing on your truck bearings, on your oil, or on your mag cylinders or your solids, that's because the surface is becoming burnt and it started wearing away. And if it's evident on the truck and the mag cylinder itself, then everything going through the press is just going to pick up the exact same habit, and you'll slowly wear away all of your system. So it's very important to keep all these things in check. To cool this, or to prevent this and certainly help it, you should be looking at having bearer wipers. And every press probably started life with it, but unfortunately in the industry we see many presses without them anymore, and those are bearer wipers. And it's just a little felt wiper which is added to the support roll and the anvil, and between the anvil and the cutter. And it adds a very small amount of lubricant onto all the system as it rotates. And it not only cools it, but it also removes any debris from that surface. They are cylindrical themselves, but not designed to rotate, they're designed to rub against the surface. And when that area that's been rubbing against the surface is completely black, all you do is then rotate it back 5 millimeters, and you've got a brand new surface there. Now, these should be impregnated previously for 24 hours in a very light viscosity oil, like 50 weight. I mean, a lot of people say, well, what oil can I use? To be honest, I always recommend car engine oil if you can use it, purely because that's what it's designed for. Pre-soak them 24 hours before you add them on, and then all that has to happen then is the press team just have to put a small amount of oil on each one before they run every single shift to maintain that consistency. Because if you do start wearing your mag cylinders out, you'll start looking at uneven die cut. As you can see an example here, this is from exactly one mag cylinder with a flexible die on it, giving 2 different applications from different sides. So if the press team get this slitted up and sent off to a customer, the customer will give you a 50% rejection. And this is what you don't want. Of course, throughout the training seminars as well, we'll look at handling of the rotary tooling and also your mag cylinders. And of course, these are sent to you in these boxes that we supply. All we ask you to do is when you put the tool back in the box, is give it a light spray of oil to keep it rust-free. But always keep it suspended in your bearing blocks, because if it's just sat on the base of the box, if anything metallic drops in it and it gets rolled around, then it's going to be dented and damaged. And the idea of this is to prevent things like this, because it's costly and it costs you money, not only in the product, but also in your setup time and rejections. And even though things like this may look comical to some, we've seen it in the past happen. You don't get a prize for Christmas for guessing what happened there, let's be honest. However, it's costly. And all this is from your top line. And of course, by adding pressure, you're creating heat. By adding pressure, yes, you can bury the cutter or bury the flexible die into the anvil itself. So on the right-hand side, we've got left-hand side there, we've got the die cutting too deep, where it's impregnating all the way through the material straight into the glassine, and that's going to snap. Or if you're cutting too light, then obviously it's not going to cut, it's not going to separate the face material, it's not going to shear the adhesive. So we're all trying to achieve the perfect cut for the least amount of hassle. And of course, this is where your AccuAdjust comes in, your adjustable anvil. You only put one amount of pressure on and you can achieve all these die strikes with the same cutter. Or if you do, for argument's sake, have a slightly worn magnetic cylinder, you've got the ability to adjust to either side as well. So to allow us to help you run smarter, all these elements have to run in tandem with each other to a high tolerance. Because as you can see from this small caption, a worn bearer means a change in the diff or the change in the air gap. And that means all you're going to be doing is chasing the ice when you're trying to achieve your die cut. We can refurbish all your cylinders, we can refurbish all your anvils, or your support rolls, and we also do a comprehensive annual or biannual inspection of all your equipment. So myself or a colleague will come into your factory and we'll check all your mag cylinders with calibrated equipment, ensuring that the air gap, 480 microns, is achieved. Make sure there's no damage to the gears. And then we'll combine that with a follow-up of a report showing you what's good, bad, and ugly, unfortunately. And it's a very easy to use traffic light system. So red is out of tolerance, green's in tolerance, and then you can decide what action you take with that then. And generally the action is when it comes back to our repair facility, where we'll take your tooling, we'll inspect it, we'll check it on the PD, we'll check the journals for any run out. If it's a solid die, we'll CNC grind that, CNC machine it, put it back into specification. And again, we do your support rolls, your anvils, your mag cylinders, and also your solid tooling. So it's back all into specification, ready for you to up and running with the least hassle. But again, I'll go back to this slide. Everything needs to be in tandem with each other. Everything needs to run in harmony with each other. So when we're adding these flexible dies into your system, when you receive them, it's an easy transition from tube to mag to press to product. Because liners and materials are very challenging, and they're more challenging so. Because back in the day, we used to have nice thick 56 micron glassines that went down to 52, that went down to 50. Now we're looking at 44 micron glassines. And it's not the fact that the glassine is getting smaller, because yes, you can achieve to change that by having a different flexible die, or you can use the AccuAdjust. The problem is thinner glassine liners is they're becoming more transparent, they're becoming tougher, but also the durometer's changing. So that wiggle room for your die cut, where we used to have 3 different tolerances, is now becoming into 1. And of course, it's exactly the same line of challenge pretty much now as you do with PET. We used to have PET 50, then PET 30, 23. Now we're looking at sub 20. And the thinner we go, it's great for the amount of labels per roll. It's great for the environment, but it's very, very difficult to manage with the die cutting. In contrast, you know, human hair is between 50 and 90 microns. We're looking at 2.5 micron accuracy. So when we're doing tight tolerance tooling, you know, please allow us to come in, give you an audit, check your things, and also help us train your staff as well. Over to you, Neil.
Thanks, Dean. Great informative presentation. I think obviously it's really important here to try and understand sort of where Dean was coming from. The discussion was primarily on sort of the housekeeping and the maintenance, and I think to always get the optimum out of your tooling requirements, it's good to have your housekeeping in order, because that does maximise the efficiency of the tooling. So what we now show here on the screen is a very condensed flexible portfolio offering. I think historically as a business we had an array of tools, probably as much as sort of 15 to 20 flexible dies over the years. We've now really streamlined that down to a core base of 4 tools, starting down at sort of the left-hand corner on the Smart Flex work, which is what we class as the economy dies, sort of running in with sort of digital applications, short run work, all the way through to the Jura series, which is the longevity die, chrome coated, can be very complex as well. And then I think we do sort of identify here in our range 2 particular dies, which we call our speciality dies. One of them being the Gold Line Special, which you can see sort of falls in line on the equilibrium with the Ultrafilm die. The Ultrafilm has probably been the big player in the market on the PET 23 work liners. And what we're now seeing, as Dean sort of touched on near the end there, he mentioned that materials are getting thinner. They are certainly going sub 20. We are currently evaluating some materials around 17 and 18 micron. And of course, they're going out to market. So what we've done is we try to refocus on the flexibles and see what flexible dies will serve that market in the sub 20. And Gold Line Special now steps into that market. It is working very well. It's a very highly complex machine die, but we've had great results actually on the sub 20 market. And then obviously we do show on there the microblade, and microblade came into the market probably in the last 18 to 24 months. It's a specialty die we developed. We developed it in one particular market and then we now expanded it out. But I'm actually going to probably allude a little bit more on that sort of as we go through this presentation, and I will show a slide on microblade and what it actually, the attribution it gives to the market, a particular product. So now we want to just sort of compare sort of longevity index table highlights here. And what I'm trying to identify is sort of the economy end of scale compared to the longevity scale. And, you know, what I'm identifying here is if we use index 1 on SmartFlex and use the index of 4 on Gold Line Special, the Gold Line Special die wouldn't be 4 times the price of a SmartFlex die. What we're trying to identify here is the longevity market, which is where everybody's trying to strive and get the best out of their dies, the maximum life. Is what we're trying to do is show you some comparables here in the market against longevity, against economy. And that's really where we as a business try and say to our customers, we always encourage you to review the price on annual usage and the commercials behind it, rather than just on today's purchase order in price, because there are many gains to be had from chrome and longevity based products out there. We always look at sort of the best solution for the best value. You know, it's key to us. We all can throw dies at jobs, but reality is it's what's the best value for the customer. And that's what we try and focus on our longevity range of products. What I sort of also want to touch on here is probably experience. I've got plenty of it. I've been doing this for over 30 years. And I think what wasn't mentioned very early on here, between the table with Thomas and Dean and myself, we've probably got collectively over 100 years of experience of knowledge in the tooling industry. But what I'm seeing now happening in our industry, designer houses, love them or hate them, they're getting very, very clever. They want everything to look very, very special in the market. And obviously they're then passing it on to you as converters with challenges that you've got to convert particular products which are very complex and very difficult. But what you're trying to do is satisfy the end goal and the end user's needs. So over this last 30 years, I've seen flexible dies come into the market and they've eroded what was typically a solid die market over many, many years. But now solid dies are sort of on the bounce back. What we're now seeing is materials are getting more complex, more challenging, more demanding, and the aggressive adhesives are getting more demanding. So we're now looking at tooling, and solid dies is very much part of that. And we've sort of got 2 core models in our portfolio. We have several others, but we have 2 core ones. One of them is the RD250. Mainly does kiss cut. It can do multi-level. It's very much a multifunctional tool, used very much in sort of the coupon work, booklet work. It can be chrome coated and is a machine finished die. And the RD300 is predominantly used in what we call the tag market, packaging, a little bit in the pharmaceutical sort of hygiene markets, very much in the medical markets, cuts metal to metal, so cuts the product out completely. And between the two of these, when they were developed, one of the key focuses we looked at was machine finishing of the tooling, because what we wanted to bring to market was replication, repeatability, and sharpness of the blade. So we do try and ask all our customers who purchase rotary dies of this nature that we do return them to us. We do machine finish. We have the capability of hand finishing, but the market is being driven by tolerance, and we believe that comes through machine finishing. So that's one of the big drivers that we have in this industry at the moment. So, from our point of view, we look at machine finishing rather than hand finishing of our solid dies. So then we have to look at waste management. And I guess waste management is clearly a market now that we see people having to diversify, look at other opportunities, look at tags. And a lot of people have always stayed away from card, tag type products because they've got to reject a product, they've got to get rid of the waste. And I think, times have moved on. We offer in our portfolio these three sort of ideal applications. With air eject, what we're actually doing is blowing air in and blowing the slug out of the die. With pin eject, we generally use a mechanical fixing. Again, we're pushing the slug out of the die. And then obviously we go down to vacuum die, which is actually the complete opposite. We take the slug into the die and we eject it through the journal. So these three are sort of how it's set up. Now, why do you need to have some sort of waste management system in your die? Because typically now when people are converting 3, 4, 5 millimeter diameter holes, what tends to happen is you die cut the product, but the die actual product doesn't fall out of the die. It actually stays within the cavity. And after maybe 16, 20 revolutions, as you see on the top, it shows you it starts to stack because it's not releasing itself. The middle part picture actually shows you the two arrows pointing at 45 degrees apart. Because what actually then happens is the pressure still remains on the jack. So you're probably running at 1200 psi of pressure loading down on the die station. You die cut the last slug, which actually fills the cavity. As the next slug tries to get in, purely the load of pressure will just go bang, and basically you will actually blow the blades off the top of the die. A lot of people hear the noise. They think it's a mechanical issue on the machine or a gearbox issue, and it's actually the die itself is actually blowing the blades off. So what we actually do for a solution, we have to look at ways of rejecting that product out to make sure we get it out of the tool and we get it ideally out of the web and in some sort of vacuum box. So one of the simplistic tools that you can use, which is very popular with us ourselves, is you see the focused air die. And basically you got the die, we bore a hole from one journal through to the other journal, and we actually put a probe down the center of the die. At the top you can see the probe, and you'll see a little slot in there. We actually position the probe because the probe does not rotate. The die rotates around the probe, but the actual slot itself, we position it at sort of 5 o'clock and 7 o'clock position. So with the airline connected to the probe, as the cavity passes the probe slot, it actually ejects the product out. The only downside you get with this type of product is one is the noise of the compressor blowing the air, and secondly is the rubbish that gets blown out. It has to go somewhere. So you either have to look at some sort of collation system, some sort of encasement around the die station, some sort of, as I see when I'm traveling, people don't necessarily have vacuum boxes. They probably have a piece of cardboard just to redirect the waste product down onto the floor, and then they basically clear it up with a brush and pan later in the day. So that's what focused air does. The other alternative to focused air is what we call multi-port. Similar sort of application, against a blowout operation, but as you can see, the die is actually made up of ports. So what we do is we drill down the die in several ports. The actual ports sit underneath the cavities themselves. So if you look at the circle on the die itself, you can see the little hole in the middle. That is where the air will actually come out. And the actual manifolds on the die, they stay static. The die rotates around the inside of the manifold. We blow air into the manifold, and as the port goes past the hole what's in the manifold, the air shoots down and blows the product out. Again, you have to have some way of collecting the rubbish that gets actually dispersed out of the die. One of the 3 pictures you can actually see, if you actually focus on the bottom picture on the left hand of the 4 pictures, what actually is showing you is an application where we currently actually die cut the product, but we don't actually blow it out. What we actually do is we actually reverse it and we actually vacuum and hold the product until it actually gets into the extractor directly above. So instead of having a vacuum box underneath, we actually place it on the top and then it takes it out from the top. So there is other applications where you may be restricted on space that we can actually put some sort of collection system on the top rather than actually having it on a multi-port die. But again, very successful die for ejecting very, very small products out of the web. So now we turn to a mechanical fixing die. A mechanical die, again, works very, very well. One of the bonuses that people always talk about mechanical types of methods is there is no noise because you don't need any compressed air. Basically, it's the spring plunger. We actually tap a hole through into the die. We screw the spring plunger in. If there is a downside, it's the size of the cavity itself that it can have, and 9.5 is the smallest cavity that we can use with spring eject, primarily because we have to tap into the die itself to hold the spring. As the die rotates, the spring as it goes round, as the spring plunger hits the anvil surface, it compresses as it comes away from the anvil surface at like 7 o'clock position, it ejects the product that's sitting. So again, very easy die, but very successful die on a small ejection process. The alternative to spring eject is what we sort of use a lot of now, is very popular, is the pin eject die. So the pin eject die is a die that's basically made up, and inside the actual central part of the die is hollowed out, and we put in there an actual rubber-based core that sits in there. The pins that actually sit in the die sit against the core itself. As it rotates and goes around onto the anvil, it compresses. As it releases from the anvil, it pops out. So a pin ejection die, the beauty of it is we can go down to 1.6 millimeter diameter cavity to be successfully ejected through pin ejection. So what I'm going to show you now is just a little video sort of concept made up of how it functions, how it works. So there you go, there's the tool itself, there's the pins that actually get put in place, and then the rubber core goes down the center. So what we actually do, you can see there the pin compresses, as it comes out, it pushes out the product. What we find obviously with pin eject, when we actually repair them, we actually take the core back out, we rotate it through 10-15 degrees, centralize it back in, and what it basically allows you to do is have a new surface area that the pin die is actually going to operate against. That's what we do following a repair when we replace pins on a die, on a pin eject die. So the next die we spoke about was the actual waste management of vacuum die. So the way vacuum dies work is there's no pushing out, it's actually sucking it in, and tend to be, if you look at the actual die itself, you see little segments. We actually engrave the cavity on a segment. You screw the segment in. Typically, a die would usually come with a backup set of segments. So you run the die as it starts to wear or show any deformation on the blade profile. You can actually replace the segment, screw it out, screw the new one in, and carry on running. Then once you've used all your segments and replacement parts, we can then get the die back. We resharpen all the segments that are on the die, and then all the spare ones we put back onto the die and the machine sharpen all those at the same time. The way vacuum works is a little bit different to how obviously ejection works the other way. Is on a vacuum die, we actually take the product into the cavity and it stays in the cavity until we fill the cavity. And basically how it works is as the last one goes in the top, it pushes the bottom one out into the hollow frame, and then you suck it out through the vacuum cleaner. We make you a bearing block, and we actually put a nozzle on there to suit the hopefully sort of the vacuum system you have, which is ideally an industrial one. I'm not talking little Henrys or little Dysons here. They won't really be sufficient for actually doing vacuuming. You do need to have like an industrial type vacuum. And on the right hand box there, we're showing you all the different types of shapes that people actually have on segments. It is a very versatile die, because if you were to get stuck on halfway through a job and you had spare segments, you can replace it. You haven't got to worry about flipping it off, get it quickly repaired, because you can actually replace the segment yourself. That's one of the core benefits of a vacuum die. It's very, very clean. We obviously see a lot of this in clean rooms. This is where it's really strong in a clean room environment, because all you're actually doing is taking the waste directly straight out into the vacuum, which you just empty at the end of the working day. This video gives you a bit of an insight, and it's very easy in principle. You can see die cuts the product, takes it in through the middle of the die, and actually ejects it out through the side journal. So we actually just bore that out and remove it from that way, from an application point of view. Very easy, very, very tidy from that source. So I think sort of, again, I guess it comes with experience. Where we've seen the market is now starting to get very complex. Some very intricate things are now starting to be produced using what I would say would typically be a laser-driven market, and is now being run and managed through flexible die technology. And we're seeing lots of things going on in RFID, antennas being produced this way, security products are moving this way. RFID, I think, if I'm being honest, maybe 10, 12, 14 years ago, was probably a word that was in the industry and was very spoken about very much. I do see now that RFID is actually turning around and actually is making a massive comeback. It's where people are looking for traceability of their products. It's why people are trying to do it now through RFID technology. And that's really what we've seen is coming very much into the marketplace as we speak. So I said earlier on, I just wanted to touch on microblade. I think microblade is something we sort of kept very close to our chest in the years of development. We developed it, brought it into the market. And the one thing with microblade, what we do show there is sort of the markets, it's sort of driven and being worked in. And clearly it is in the RFID market. This isn't really being used directly on the insertion of them. This is being used on some of the manufacturing processes within RFID technology, which again was typically laser driven. And what we're now seeing with the opportunity, again, the blades so close together, sort of 0.6 millimeters apart. If I go back pre-development, we were probably talking most blades traditionally would be around 0.9 to 1 millimeter. So we've taken 30 to 40% of decreasing that down on the 0.6 of microblade. Microblade within our operational facilities around the world, we are only able to manufacture it at 2 of our sites, one being in Germany and one being in the US. And that's primarily because of the technology required on what supports the development of microblade and how it gets finished on a special manufacturing process in those 2 sites. So a little bit of touch on here, we've touched on sort of intricate spacings using microblade, and now I just want to sort of give you a bit of idea on the converting side. We do have Tidland very much part of our organisation, but Tidland create knives. We're now obviously able to use self-adjusting knives in the Tidland shafts. And then we as a company, as RotoMetrics, we're obviously looking at the way the market's wanting to go. And I think the market wants to get away from mechanically moving blades, want to get away from mechanically adjusting blades on depths of cuts. And we've always had units out there called RD, an RD score unit, slitting unit. And what we've now done is return them into automation, the next generation. And we're now able to create an auto slit and auto score unit utilizing HDMI panel. So there's nobody putting their hands in the machine anymore. We can actually set the panel to correct and automatically position the knives to where we want them to be. We can also automatically adjust the depth of cut through the HDMI panel. Again, it's pretty unique. Not many people are able to do that. People are able to position, but they're not able to do the depth of cut, which is something we're bringing on. And the next thing we just want to talk about is RotoMetrics, which is our award-winning non-stick coating. And I know the award says back in 2018, and we're now 7 years on. RotoMetrics clearly is a market leader in the non-stick world. We know the market is challenged with adhesives, and adhesives are getting very aggressive, whether they be rubber-based, less so acrylic, but probably rubber-based hot melt adhesives. And just a bit of imagery here just to show you some of these high-tech adhesives. And what we're having to combat now on a press at speed is to try and stop the adhesive building up and holding on to the product. And what we're now seeing is we're being asked and challenged by saying, can you make the blade sharper to cut through the adhesive? I think we understand die cutting, and the majority of the issues that people actually experience is actually not through the die cut going in. It's actually when the die cut comes out, it actually drags the adhesive to the surface. And that obviously then encourages materials to start to bleed a little bit more. Obviously, in the summer, materials tend to bleed a lot more because of the heat. What we do with RotoMetrics, I think we've been very, very successful with RotoMetrics. We apply it on a chrome-based product, so on our flexible dies, it's generally in the Prime and the Dura range. We can apply RotoMetrics. When we apply solid dies, when we have dies battery sharpened, we remove the coating, we remove the chrome, we sharpen the die, we recoat the chrome, we recoat the RotoMetrics. So the die comes back to you as good as new. But RotoMetrics, it's easy to clean, hardly picks up any adhesive, lessens the chance of adhesive bleed. So we're actually now seeing RotoMetrics probably being used on a fair portion of our dies that we produce every day, and people are tending to move because it is improving the performance on the press. How RotoMetrics compares to a traditional non-stick, and probably what I'm trying to show here is not the non-stick of a competitor. I'm actually trying to show this as a comparison to what was our traditional non-stick coating. And basically, when you actually apply a non-stick, even though the blade is to a penultimate point, what we find is a traditional non-stick probably puts about 10 microns of flap on the top of the die. So it actually starts to round off the tip. What we find with RotoMetrics, it probably puts around 3 microns. So it's very cleverly how we actually put it to the die. And when you actually look at this as a comparison, so what we did, we actually ran the same die. We actually coated it in a traditional non-stick, and we actually, after 20,000 revolutions, as you can see, the actual coating itself started to break away from the blades, and the adhesive started to apply itself to the blades. So basically, at this stage, you'd be stopping the run because you'd have no success. What we found with RotoMetrics, with the same die, we actually took off the traditional non-stick, replaced it with RotoMetrics coating, and actually after 40,000 revolutions, so twice as much revolutions, you can see under the magnification, with no adhesive and no RotoMetrics breaking up on the surface of the die. So this is why I just want to show the success of RotoMetrics. Die cutting solutions, what we see now is challenging new people. They're getting more complex, they're getting more demanding on the operators. And I think where we as a business are trying to look at, which is similar to what Dean was trying to build up the foundation in your business, what we're looking at now is actually running the applications itself. There you go. So I just want to not go back through this, obviously what Dean spoke about, but we know your challenges of substrate adhesives converting. And I think, people now are looking at automation. We're certainly looking at automation in our own production lines. We're trying to pass that on to you people with all the benefits that we obviously are creating through our systems. But what we're trying to do with you people is try and help your machines out. And one of the products that we sort of have been working very hard on is an adjustable anvil system. And I think historically, we as a business have had adjustable anvils. We've been, to be honest, in the market like our competitors for 30 or 40 years. But what we looked at in development a few years ago, and we worked with the R&D team within the Maxcess group, and I think one of the challenges we gave them, and I was one of the people who spoke on that meeting, was to say, I think what we need to bring to the industry is an adjustable anvil that is simplistic, very functional, but is not governed by the experience of the operator. I think, you know, we as a business, and I travel, Dean, and we all travel around, and we see it, we talk to operators, and there's some very, very clever systems out there, and the dials at the front, and they all carry a function of changing the bearer heights or changing the body heights. And I think we want to get away from that, because by myself talking to production managers, and I'd say, so why doesn't Brian work on that machine? He can't work on that machine because the adjustable anvil is a bit complex. So what we try to do is take away experience level out of it, and we brought in AccuAdjust. It had 2 intuitive controllers, digital readout, which is great because the operator can clearly see identify what is changing the pressures. But what we also done is built a foundation model called AccuAdjust, which we can then build on with automation. We can go to RotoAdjust, and then we can go to RotoScan. RotoScan is probably the Rolls-Royce end of the market, and we have a launch date of it in sort of the middle of next year in 2026. But what I'm now going to show you is a video which shows you the AccuAdjust, RotoAdjust, and then the RotoScan. I'm just going to talk you through some of the changes, as you can see, as you build on the model. So we call it as easy as 1, 2, 3. So number 1 is the AccuAdjust. You can see the 2 intuitive controllers on the top. Each click is 1.3 microns of change. It gives you individual bearer control and anvil up and down movement. The reason you require that is because not all your magnetic cylinders are running equal on the anvil. So if you have any defects within the magnetic cylinders, we're able to compensate for that within the adjustable anvil by moving the anvil up and down side to side. So what it allows you to do is then go to an upgrade of RotoAdjust. And in simple terms, what we do with RotoAdjust is we remove the intuitive controllers, and we now give you a HDMI panel, and you still control the movement through step motors through the HDMI panel. Still allows you to go up and down, front to back, but also allows you to drive from the HDMI panel a lot of analytics, which will come onto a laptop, which I'll show you very shortly. But basically what this does is it allows you to control a die cut which is heavy on one side and light on another, basically to get you equilibrium across the web. We can connect this straight directly to your own network, so you can monitor die life, you can scan in your mag cylinders, you can scan in your flexible dies, you get run length, you get all the data you require, you can buy directly off the system. Full automation, which is the next generation, which is the exciting tool we're bringing out next year. We showed at Label Expo this year is RotoScan. What is RotoScan? So RotoScan basically is what I would call an X-ray machine. It's actually X-rays your line of strike. But instead of actually your operator testing the roll at the beginning and then 4,000 meters later, he tests the roll again and he finds it now cutting through. The clever bit about RotoScan, it actually does it on the fly. So you're running at 200 meters a minute and your die cut starts to vary away from what you've actually calibrated it for. So hypothetically, materials have a tolerance band of about 10%. We say if you put in a judgmental up and down of maybe 6%, so you've got a maximum of 12%, the actual RotoScan system will actually scan your liner. If it starts to deform and fall out of the 6% range, it will actually inform you on the HDMI panel. So it's actually telling you there's a fault going on the run. So you're able to then use your flag markers, put it into your web. 10 or 15 meters later, it corrects it back in line. You mark it again. You get to the end of your 4,000 meter roll. You know exactly where your fault was on the run. At the moment, you wouldn't know that, because you're relying on the operator finding it at the end of the run. So that's really where RotoScan, launch date hopefully sort of June next year, currently being beta tested at a couple of sites in the US. Until we get all that data back, we'll then go for launch. So that ends me, Andy, and probably hands it back to you.
Okay, great. Thanks very much, Neil. Great stuff. So it's time now for some questions. We've got a bit of time left. I've got a few questions, and we've had a couple that have been sent in from the people viewing as well. Just to start off with, from me, what's the value of using Hydra jacks to apply pressure?
I'll take that one if you want. Clearly, if you don't have hydro jacks and you obviously have just mechanical jacks, we call it the white knuckle effect, because basically it depends how white your knuckles get, depends on how much pressure you put down on the dies. What you don't and not able to match is we're all either right-handed or left-handed. So whichever, if you're right-handed, your right jack, what you touch when you put your pressure on, will always apply more pressure than your left jack. So if you've got no way of reading what loading you're putting down, you're always going to wear dies quicker than probably what they're scoped to do. Because if you have something that gives you a reading, it doesn't matter which operator controls it, what you're able to do. And we give a guide of around 120 psi of pressure per inch of crossblade. So hypothetically, you're running 6 inches across your web, which is 720 psi of pressure. So you should be running, in the ideal world, around 360 psi of pressure per jack. So it gives you a guide of where you should be. Without sort of a jack or sort of pressure gauge method, you have no way of knowing what loading you put in die. And that's why people get short die life, because they overload dies because they're not realizing they're overloading them until they see the die strike and what they've cut through on the press. So hopefully that gives you a bit of an understanding why some form of pressure loading is very, very important.
Okay. Right, thanks very much. The next question is from a member of our audience, Lee Hong, who asks, can flexible tools replace solid tools? Over to you.
Yeah, I'll take that one. So can flexible tools replace solid tools? In all honesty, I don't think it can fully replace a solid tool, purely because the solid tool does a lot more different materials, thicknesses. I mean, the flexible die was really brought into the market, firstly and foremost, for quick changeovers and short runs. Yes, as Neil said it through in the presentation, what you've got is you've got now longer life flexible dies, which we can coat, we can laser harden, we can change certain degrees of the angles of the tip. But at the end of the day, it's still a fire and forget product, as we call it, because you're only going to get a certain amount of meterage out of it before it goes in the bin. Your solid tool, we can do a hell of a lot more. It's more durable. The durometers are harder. It's more wear resistant. We can add a lot more coatings, and also we can resharpen it several times. Plus, on top of that, you can do a lot more different materials with a solid tool. So, can it replace it? Not fully in all aspects, but it is used in the industry. Yes.
But you could say, and want to do it in a popular way, that flex dies is capable to anything up to 1.2 millimeter, yeah. And after 1.2 millimeter, you basically have to go to solid dies unless it's a compressible material you're talking about.
Okay, right. Another question from me. Yeah. What's the best way to account for liner thickness variation?
Well, there's two ways liner variation. First of all, you should be contacting your material supplier and asking them not to send different liner variations. No, only joking. To combat it, it's very, very difficult because you're set with a liner. It's as simple as that. What you can do is you can obviously use an AccuAdjust, where you can change the body of the anvil itself up to the blade, so you can compensate for that. But you still are going to have heavy areas if it's that uneven. At the end of the day, this is what we're trying to highlight to material manufacturers. We're looking at the peaks and troughs in the liner so we can hit the sweet spots, especially when we're converting polyethylenes, because we do have to kiss the liner quite keenly. Where people want light applications, where they're pushing away from the liner, they don't want any marking, then that variation in the liners, and especially craft liners, is probably most paramount. So variation-wise, yes, you can adjust it if you've got the right kit. Yes, you can apply pressure on it, but then you're going to damage the tool. You're also going to damage the system. So really, anybody who's got vast liner variation should be really turning to the manufacturers of the material asking for help.
Okay, right. Thanks for that, Dean. Another question. This is from Tim Pearson, who asks, with an adjustable anvil, is it best practice to just run one pressure and adjust your cut depth with the adjustable anvils?
Yes, Tim, that's a quick answer, and the answer is definitely yes. Because with your conventional system where you're using hydrojacks or without hydrojacks, all you're doing is you're doing the touchy-feely thing and adding as much pressure as possible. And as the tool wears, or if you've got a very wide cross blade, which is going to need more pressure, you'll add the pressure to compensate for that. With the adjustable anvil, you'll only set it on one pressure, and that pressure is dependent on the press size as well. So, for argument's sake, like a 14-inch press, you're probably going to put 800 psi on each gauge and never move it again. And then all you'll do is, as you're changing your materials, if it goes from a PET liner into a craft liner into a glassine liner, you'll just adjust the height of the anvil surface to accommodate for that depth then.
Okay. Yeah, cool. Thanks very much. Okay. Another question from the audience. This is from Mike Hunt. His question is, do you charge for audits and training?
Good question. Reality is we obviously do have charges for anvil audits and training, because clearly the cost element, I have to use technical experts like Dean Morris and mechanical engineers like Stephen Jackson and team. But I think it's sorted for courses. We work with all our customers. We obviously try and encourage people to have training. We try and encourage them to certainly get the mag audits done, because clearly having mag audits done and having good mag cylinders gives you good die cutting. So that obviously takes a lot of pain from a lot of scenarios. So all I say is yes, but obviously people can talk to me, they can email me direct, and I'll work with people. It's all about a collaboration. We're a company who try and work in partnerships with companies, and we see we work in some companies and they do beta testing for us, and it's sort of we encourage them to get training done, and Dean does a lot of the training within our organisation. So yeah, all I say is talk to me and we'll see what can be done and work within every individual company out there.
Okay, thanks very much, Neil. So we're getting very close to the end, but perhaps time for one more question, I reckon. Another one from our audience. This is from Rowan Lilly, who says, great informative talk. What is the best way to clean a die if we do see any adhesive buildup? Is there anything that should be avoided?
Yes, essentially. Basically, Rowan, first of all, if you've got adhesive buildup on the tool itself, depending on what the tool is, whether it's a solid tool or a flexible tool, you can pre-soak it in an isopropanol, depending on whether it's got rotor repel on or not. You should never use anything metallic, essentially. Unfortunately, over the years, I've seen people using all types of metallic objects trying to remove adhesive. So the easiest thing to say is, a perfectly old toothbrush is perfect for removing stubborn adhesives after you've applied, an anti-coagulant. Ideally, if you are seeing these things, you should be getting in touch with, our customer service team, where we can apply the rotor repel coating to reduce that, and that's ideally what it's there for.
Okay, great stuff. Thanks for that, Dean. So our time is pretty much up. So we've come to the end of the webinar. It's been our pleasure to present to you today. We've heard a great deal about the challenges and potential solutions around die cutting and converting different materials, whether substrates or adhesives. We've also heard about different waste management solutions in die cutting, when and where they are most appropriate. So thanks from me to our speakers, to Thomas Eberhardt, Neil Lilly and Dean Morris, for sharing their knowledge and expertise and answering your questions today. And thank you to you, our audience, for joining us and listening in. We hope you've heard illuminating information and picked up some great insights that will help to make your die cutting smarter and more efficient. Shortly, you'll receive an email with a link to the session so that you can go back and listen again. Thanks once more. We wish you productive and perfect die cutting. Thank you. And